Alright, so technically, today we'll be talking about tangential function, but technically the tangential function, or the tangent, is actually made up of tangent of theta is actually equal to when you take sine of theta and divide it by cosine of theta. Okay? Why is it that way? I don't know. It just works that way. It's weird how it works that way. But if you remember, working with sine was y and cosine was x. Okay? Tangent is just if we took y divided by x. And if you remember, if you take a look at your actual information, you'll see, oh yeah, that does work out that way. Okay? Like for example, if we were working with inside of our unit circle and we drew a triangle that looked like this, okay, here's my x, here's my y, okay, and here's my actual theta, okay, sine would just be this, cosine would just be this. Well, tangent is opposite over adjacent, okay, and so that's where we get the y over x. That's really kind of cool how it works that way. Okay, let's take a look at the curve. Alright, so here's the actual tangent line. Okay, now this is what happens when you take this right here and then you divide the results by right here. Okay, alright, so there's some unique overlap when we work with this. Okay, and we're going to look at the overlap with the actual sine function. Okay, alright, now if you notice, wherever sine is equal to 0, tangent is also equal to 0, and that's not a coincidence. Okay, because if you think about it, if sine is 0, your top number, if you remember the top part is 0 over whatever, it's going to be 0. Okay, unless this bottom part is 0, which they are never, because remember, this is shifted over, so there's no way that these two could ever be 0 at the same time. At the same angle value. They could be zeros at different times. Like for example, when x is, or when theta is 0, sine is 0, but when theta is negative pi halves, cosine is 0. So that, once again, just proving the fact that those two are not going to be equal at the same time. Okay, so some interesting things about that. Now, if you notice when sine is -1 or 1, however, there seems to be some discrepancies to what tangent's going to be equal. Well, if you notice, it's going to go down forever, but it's never going to touch pi halves, and it's never going to touch pi halves from this side. So what that means is that my actual graph, okay, of tangent is going to be undefined when sine is some positive, when the results of sine is going to be 1 or -1 as a value, or it's at pi halves or negative pi halves, whichever one you want to define. Okay, all right, let's take a look at cosine. All right, now cosine, wherever cosine is 0, tangent is undefined, and wherever cosine is 1 or -1, tangent is going to be 0. So that's some interesting properties right there that work with it. So just so you know, these aren't coincidences that these pop up, but they do make sense when you think of tangent in terms of sine divided by cosine. Okay? Alright, now is amplitude affected the same way on it? Yes, it actually is, except it's going to be stretched out more. So the bigger I make it, the more stretched out it's going to be upwards, and the smaller I make it, the more compressed it's going to be, and then I make it negative and it flips over the x-axis. Okay, now B, does it affect the period? Well, first off, let's look at the period for this. Okay, the period is going to be, instead of from 0 to 2 pi, it's going to be from 0 to pi. Okay, so if I increase B, I'm going to definitely compress it, and it's going to be even compressed even more so than usual. Okay. The cool thing is if I make it negative, it will flip it over that direction. But yes, B does compress it, but with tangent, our period is no longer for one wavelength from 0 to 2 pi, it is actually from 0 to pi. Okay, so let's take a look at that and how that affects our rule. Alright, So this is our parent graph right here, y equals tangent of theta, okay? And we've added the values of a and b into it. Do they affect anything? Yes, not as different as what you think with cosine and sine. Amplitude is just going to stay the same of what it is. Now period is the new one right here, so period is definitely going to be changed because the period of length for a one wavelength of tangent to happen is actually just pi. Okay, so this is only for pi. Oh, I'm sorry, only for tangent. Only for pi. Yeah, no kidding, it's only for pi. Okay, so it's only for tangent as we work on this stuff. All right, now the cool stuff is now you have two more rules to actually work with tangent graphs to actually find the amplitude and the period. Okay, now b is actually going to be the amount of wavelengths within one period of pi. Okay, whereas this is actually the length of one period for one, wavelength as we go. Okay, all right, that's it for tangential curves. I'll talk to you later. Bye.